Systems of equations. Okay, copy the title. So, what is a system of equation? Basically, it's having more than one equation. That is pretty much it. If you have two equations, you already have a system of equations. Okay, so just like in equations, when the number of solutions or the number of possible solutions was equal to the number of the greatest degree of the exponent of the variable. So here, the number of required equations is equal to the number of variables, which means if you have two variables, means that you require two different equations to solve it, which means you cannot solve an equation an equation with two variables with just one equation. So you have three variables, you need three equations, and so on and so forth. Now, the form of your system of equation usually contains two equations and usually something like this. So you have something x plus b is equal to y, and then something x minus y is equal to negative b. Whatever form they show, they usually x and y or a and b or c and d. Okay, pause the video, copy this. We're going to move on. Okay, linear equations. We're going to work with systems of linear equations. So when we have two different equations, so we have, let's say, 3x plus y and then have 4x plus 7y and they are equal to different thing, it means there is one solution for this system of equations. When we have the same equation but in different forms, which means just by looking at them, they don't look the same. So I have 3x plus y equals to 5, and then 6x plus 2y is equal to 10. But if you notice, like this is pretty much the same by times 2. So 3x times 2 is 6x, y times 2 is 2y, and 5 times 2 is 10, which means it's the same equation, it's just having different forms. I have infinite solutions. And finally, when I have the same equation but different constants, meaning they have the same slope. So if you already know the concept of slope, it just means that they have the same slope. If you don't know the concept of slope, don't worry, we're going to look at it. But basically, it's like the same equation. So I have 3x plus y, 6x plus 2y is like times 2, right? So 3 times 2 is 6, y times 2 is 2y, but 5 times 2 is not 11. 5 times 2 is 10. So when I have the discrepancy, it means there are no solutions. When I have a system of linear equations, of two linear equations, I only have three possibilities: either one solution, infinite solutions, and no solutions. A system of linear equations cannot have two solutions, three solutions, four solutions. If you ever see a question like that, you know the answer can only be one, zero, or infinite. Pause the video, copy everything you see, everything. I'm going to continue. Okay, we're gonna do these exercises. I want you to pause the video right now. I don't need you to solve the solution, these equations. I do not need you to find x and y. All I want you to tell me is how many solutions. This is all I want you to tell me. Okay, pause the video, find this, write your answer, and we're gonna move on. We're gonna check. Okay, so in the first one, 3x plus 7y is equal to 15, 4x plus 7y is equal to 13. The first thing we're going to do is we're going to try to see whether they are the same equation or the same equation with different variables. As soon as I see that the 7y is the same, so if they were the same equation, then the x had to be the same and the constant had to be the same, and they are not, which means they are not the same. They are different equations, so they have one solution. Let's look at number 2. 5x minus 8y, 4x minus 8y, they have the same constant, they have the same y, but they have different x's. So one solution, because they are different equations. They are not the same equation, and they are not the same equation with different constant. Let's look at number 3. I have 34y minus 12x equals to 0, 34y minus 12x is equal to 2, which means they have the same equation but different constant. So they have zero solutions. There are no solutions, same equation, different constants. You can look at this like they have the same slope. Number 4, 7y and 2x, 6x and 21y. Now, this is trying to confuse you because in the first case, they put first the y and then the x, and in the second case, they put first the x and then the y. But I'm going to look for them, or I'm going to reorder them, and you're going to see that when you take the 2x and you multiply times 3, gives you 6x times 3. And when you take the 7y and you multiply times 3, gives you the 21. Yes, so this times 3. And if you take the 13 and multiply times 3, it also gives you 39, which means they are the same equation, which is they have infinite many solutions. They are infinite solutions because they are the same equation in different forms. Okay, let's look at number 5. I have negative 24x minus 3y is equal to 12, and then 13x plus 23y is equal to 2. So I'm going to try to make them equal, but just by looking at them, you can see that they are not the same equation, and they are not the same equation with different constants. They are different equations, so they have one solution. And finally, the last one, y is equal to 23x plus 4, or y is equal to 3x minus 5. You can clearly see that they are different equations, so they have one solution. So these are the answers. Pause the video, copy this, and we are going to move on. Okay. We are going to move on to graphing the system of equations. So we already saw that one solution, no solution, infinite solution. How does this translate to the graph? Well, the solutions in general, you do have to copy these. Solutions is just the intersection points. In a graph, we call solutions to the intersection points. When you see two lines intersecting or a parabola intersecting or a line intersecting to the plane, that's called a solution. That's it. So when they have one solution, it means there is one intersecting point. That's it. At any angle, they don't necessarily have to be perpendicular. Okay, any angle, as long as they cross, that's one solution. When you have no solution, it means they are never going to intersect. And how do we call things that never intersect? Well, in the case of lines, we call them parallel lines. So when they are the same equation, no solution, they are parallel lines. And when they have infinite solution, and I said is like the same equation in different forms, it's basically we're just looking at 2 points of the same line. It's basically just the same line. Okay, pause the video, copy all of these, draw the lines, draw the graphs, and we're gonna move on. Okay, so a strategy for system of equations. So how do we solve a system of equations? Well, we're gonna do it by equating them, substitution, or elimination. By equating them, all we're going to do is we're going to put both equations on this form. So y equals to something, and then we're going to equate it. So if I have 3x plus y is equal to 3, and then I have 3x is equal to y minus 7, what I'm going to do is I'm going to put both in this form, which means I'm going to leave the y alone. So I'm going to be y is equal to 3 minus 3x in the first case, and in the second case, y is equal to 3x plus 7. And then I'm going to equate the parts that don't have the y. So 3 minus 3x is equal to 3x plus 7. And then I just keep solving for dx. That's going to give me dx for the system of equation. What is the second strategy? Substitution. I'm going to isolate a variable and then I'm going to replace the value. So when I have 3x plus y is equal to 3, I'm going to find y in terms of x or x in terms of y, and I'm going to replace it in the second equation. And finally, I do it by elimination. So instead of moving from one side to the other side, I'm going to do it vertically. I'm going to explain the second and third strategies in a moment. I want you to pause the video right now, copy everything, and I'm going to explain substitution and elimination. Okay, so this is how substitution and elimination work. So I have this equation, this system of equations right here. So substitution works like I just put everything in terms of y or in terms of x. In this case, x is equal to 15 plus 2y over 5. And then I replace in the second equation. So where I see an x, instead of putting an x, I'm going to put the values that I have for y. And I keep solving accordingly until I get the value of y and the value of x. That's one way of doing it. The other way of doing it is doing vertically. So I'm going to put my two original equations, okay? And then what I'm going to do is I'm going to see whether if I just multiply times something, I can make them have one of the terms equal. So in this case, I'm not looking for making the two terms equal because they are not the same equation. So in this case, I'm going to multiply times 2. And if you notice, if I multiply times 2, right, I'm going to pause this here. I'm going to get 10x and then minus 4y. Sorry about this. So I get 10x, 5x times 2 is 10x, and then 2y times 2 is 4y equals to 15 times 2, which is 30. And now what I'm going to do is I'm going to subtract. Since I already equated one of the variables, that's the variable I'm going to eliminate. So which means I'm going to just subtract in terms of what is convenient for me, usually by trying to make the other variable positive. Again, if you do it negative, doesn't really matter. You can always get the answer. We're just trying to work with positive numbers for convenience because it's easier and faster. So we're going to subtract from bottom up. So 10x minus 10x is 0. And then have 6y minus 4y. So it ends up being 6y plus 4y gives me 10y. And then 45 minus 30 is 15. So y is equal to 1.5. After I find one of the variables, I can just replace in any of the equations to get the second variable. Now, when we use this method, sometimes it's easier, sometimes it's easier to use the first method, but the important thing is that we're going to focus on the question, so on the variable that they're asking us. So if they're asking us for y, we don't want to find x. We want to eliminate the x. So we want to eliminate the one that we don't want. So we choose to multiply times a number that's going to help us eliminate the variable that we are not looking for. Okay, I want you to pause the video right now, copy everything, and we're going to move on. Okay, I want you to do this example over here, pause the video, use whatever method you need to use, and we're going to solve this question, write down the answer, and we're going to solve it. Okay, here they're asking us for A. They're not asking us for X. They're not asking us for Y. They're asking us for A. So one thing that we're going to do is we're going to see that this is a system of equations, but we're going to read the question, because in the question that tells us that it has no solution, which means they're giving us extra information. They're not just leaving a system of equations for us to solve. They're giving us theoretical information. Now, when does a system doesn't have a solution? Oh, when there are parallel lines, or you can say when they have the same variables but with a different constant. So which means these 3y and this negative 2y, they have to be the same, which means they're proportional. We already saw the topic of proportion, which means there's something I can multiply the 3y times something, so I can give me the negative 12y. So what happens is I'm multiplying times negative 4. So 3y times negative 4 gives me negative 12y. And I can check that if I multiply negative 2 times negative 4 gives me 8, which is going to be a different constant, and that's okay because I want a different constant. Again, no solution means the same equation, different constants. So now all I'll have to do is multiply the 4 times negative 4, and it's going to give me negative ax. Now, a trick here is that 4 times negative 4 is negative 16, right? Negative 16x. But negative 16x is equal to negative ax, which means a is not negative. A is going to be positive 16 because negative 16 is equal to negative a, so both are positive. So the answer will be 16. Pause the video, copy. We are going to move on to the next one. Pause the video right here. And I want you to solve this question, write down the answer, and we're going to check. Okay, here they say this is a system of equations, m and n and constants, and the system has infinitely many solutions. So we check what we copy. When does a system have infinite many solutions? Oh, when it's the same line, which means it's basically the same equation. So all I have to do is again find the proportion. So 8 times 4 gives me 32, which means 3 times 4 is going to give me m, and 5 times 4 is going to give me n. So m is going to be 3 times 4, and n is going to be 5 times 4. So this is 12, and this is 20. So basically m plus n is 32 because it's 12 plus 20. Okay, pause the video right here. Copy this. We're going to do the last exercise, which is this question. Read the question very carefully so you can solve this question. Pause the video, solve this question, write down the answer. Okay, we have a very big system. This is a graph, but we want to look at the question. The question is, how many solutions does the system have? Remember, the very first thing I told you is that solutions, well, not the very first, but one of the first things I told you in this video is that solutions equal intersection. Basically, they're asking us how many intersections they have. So all we have to do is find, okay, intersects once, intersect twice. The answer is 2. That's it. Now, an important thing is that this is how many intersections the system have. We're not looking for the intersection with the graph. We're not looking for these intersections. We are looking for the intersections of one of the lines with the other line. All we have to do is count how many times they cross. And that's it. 2 is the answer. Okay, now we are going to do some questions from Digital CT. Pause the video right now. Solve this question, write down the answer, and we're going to check. Okay, they tell us the solution to the given system of equations is x comma y. What is the value of x? Here we can apply the method of replacing one value. So they say y is equal to negative 3x. So we can replace y. Whenever I see the y, I replace with negative 3x. So I have 4x minus 3x is equal to 15. So I have x is equal to 15. And this is the answer, just by replacing. Okay, we're going to go to number 2. Pause the video right now. Solve this, write down the answer, and we're going to check. Okay, which order pair is a solution to the given system of equations? So they give us a system of equation here. We can expand on the system of equation. Basically, there are 2 ways of doing this. Since you have alternatives, my advice is you can just plug in if you want to. You just plug in 3, 3, 3, because if you see all of the alternatives have 3 as the x. So basically, all we're going to do is just plug in the 3, right? So I put, okay, 3 plus 7 is 10, yes. Now let's plug in what happens when I have my 3 here. So I have 3 plus 7, 10. 10 squared is 100. So y is equal to 100. And that's it. That's my solution. Letter A is my solution. Is there another way of solving it? Yes, but trust me, this is the faster way. Now, the other way, of course, will be solving it finding the x, which is totally fine because if you notice, the first equation already gives us the x. So x is equal to 10 minus 7, so x is equal to 3. And now with this value, I replace here, which is going to end, I'm going to end up in the same position. So I have 3 plus 7 square is equal to y. So I have 10 square is equal to y. So 100 is equal to y. And I end up with the same values, 3 comma 100, which is letter A. Okay, pause the video, copy this if you have to copy. These are the answers. If you want to practice more, these are the pages of the Panda book and the Barron's book where you have more system of equations exercises. And we're going to continue with the theory.